In 2.4, we are going to look at some new examples, but content-wise, this is going to be a big review from some of the stuff that we saw in Unit 1 and kind of building upon that as we move through Unit 2. So just kind of starting out, we're looking at characteristics of linear functions, and we already know quite a bit about linear functions. We already saw in Unit 1 that we know how to do slope, we know how to use point slope, we know about intercepts. And so let's just kind of do a quick review. A linear function is a function whose graph is a line. Linear functions can be written in slope-intercept form. Notice they're just using function notation here. That's the same as a y, where b is the initial or starting value of the function, and m is the constant rate of change or slope of the function, and the y-intercept is 0, b. So none of that is new information. They're just using function notation. But here are some of the new examples I want to show you here. In part A, it says linear functions in tabular form. So if you were looking at a table of values, trying to figure out if that is a function or not, a linear function, then you're going to be looking for constant change, because we know that the slope of a linear function is the same for the entire line. So basically, we're looking for the change in y over the change in x to be consistent. And so you'll notice this is an example of my x and my y. We're just calling it t and dt using that function notation. And as this is going up 1 second, 1 second, 1 second, it's going up 83 meters, 83 meters, 83 meters. So the change in y is 83 over the change in x is 1. And so it has a constant slope or a constant increase in this manner. So a tabular representation of this function is showing select inputs and outputs. Let's look at another example, and you'll have one similar to this in your homework, and make sure we can kind of do it on our own. So it says select which of the following tables could satisfy a linear function. So we're looking for a rate of change, average rate of change, or slope that's consistent as 1 increases. So you'll notice here, I'm increasing plus 5, plus 5, plus 5. So I have a constant change going up. And then over here, I'm decreasing by 25, by 25, by 25. And so if I were to do 25 over that 5, I would get a negative 5. And so you can see I have a constant change going on. I've got the same slope going on between any 2 points. So this will be a linear function. Let's look at this one. This one's going up by positive 5, positive 5, positive 5. So just think 10 minus 5 is a positive 5. And then you'll notice over here from 7 to 32, that's a difference of plus 25. From 32 to 107, that's plus 75. And from 107 to 232, that's a plus 125. So if I was to take any of these two given points, I would not get the same slope every time. But in a straight line or a linear function, you should. So because I didn't have a constant increase or decrease as I was moving through these points, this is not a linear function. Notice over here it's going up by plus 5 each time. And over here we're going up by plus 25, plus 25, plus 25. So this would be representative of a linear function. Last one, we're going up by plus 5, plus 10, plus 5. On this other side, we went up by plus 20, by plus 40, by plus 20. So notice here, between 5 to 10, we went up 20 units. From 5 to 10, we went up 20 units. When they made this big jump, they doubled this jump, so this jump should double, and it did. So this is also a function, because again, notice, if I did 20 divided by 5, that'd be 4. 40 divided by 10, that'd be 4. 20 divided by 5, that'd be 4. So the slope between any of these 2 points still gives me a value of 4. So this is still a linear function. Even though they jumped over this one spot, they doubled up how much they increased by, so it's still increasing at the same rate and would create a linear function. Another way I want to look at linear functions is just by looking at a graph. We honed in on quite a few parent functions as we're working through sections 7, 8, and 9 in Unit 1. And so here you should see similar results. Select the graph that represents a linear function. This is also a question on your last exam of drawing parent functions. So which one of these is linear? It would be this one right here. If you remember from parent functions, this one's parent would be x cubed. This one's parent would be x squared. and this one's parent would be square root of x. They've all been transformed in some way, like we saw in the earlier section. But which one is a linear function? Just the one with the straight line. Also not new to us is talking about increasing and decreasing, and we talked about this in Unit 1. If we have an increasing function, you read graphs from left to right. So increasing, you can see it's going up. Decreasing, we can see it's going down. Constant function is just a horizontal line. It has a slope of 0. So I just wanted to make sure we have this somewhere in our notes. We review and go over some of this and make sure we understand we're all on the same page. The last part of the review is review of creating linear functions. So our process is 1, we're going to have to calculate slope. Then 2, we're going to have to use a point and a slope to find the equation. So a quick review of formulas that you already know, and I just threw them at the end here in the summary. Remember, slope-intercept form of a line is y equals mx plus b. Slope is the change in the output over the change in the input, or a rise over run. We also say it's delta y over delta x, or the thing that we're going to use the most, y2 minus y1 over x2 minus x1, and then point slope form of a line. And so I want to just make sure we have this in our notes, go back to that. Hopefully you already have that memorized from the first unit. So let's work these 2 examples. Again, not a bad section. If f of x is a linear function and 3, -2, and 8, 1 are points on the line, find the slope in this function. Find the slope. Is this function increasing or is this function decreasing? So the first thing we're going to have to do is find slope. So I'm going to remember my slope formula, and we also have it down at the bottom of this page. y2 minus y1 over x2 minus x1. And so I always like to label it. x1, y1, x2, y2. And then I'm going to work out my equations. So I'm going to go ahead and write my formula, just a real template here. I'm going to have my minuses in there. y2 is 1. y1 is -2. x2 is 8. x1 is 3. Do my arithmetic across the top. 1 minus -2 gives me +3. 8 minus 3 gives me 5. So this would be my slope of that line. So it said find the slope. We did. Is this function increasing or decreasing? Well, if it's a positive slope, it's going to be increasing. If it's a negative slope, it's going to be decreasing. So this one would have an increasing function. So get number 2. Find the slope of the line that goes through the points. Enter your answer as an integer or a reduced fraction in the form of a over b. So again, I'm just doing slope. So I'm going to write my formula. I'm going to go ahead and set up my fraction bar with my minuses from my formula so I don't mess up my negatives. I'm going to label x1, y1, x2, y2. And then I'm going to plug in. y2 is -5, y1 is 10. x2 is -2, x1 is -10. Then we'll work my arithmetic across the top. -5 minus 10 gives me -15. Use your calculator to aid you with these negatives if you always struggle with them. -2 minus -10 is like adding 10 to it, so it gives me a +8. And I can't reduce this in any way, so I'm just going to leave it as -15 over 8. If this question went further, like the previous one, asked if it was increasing or decreasing, I could say that this one is decreasing, and that's because it's a negative slope. So really this section is not super new concepts. It does add in the linear functions on a graph and on a table, but I want to make sure you understood and reviewed some of these formulas from the first unit and had them fresh on your mind. If you have any questions along the way, feel free to contact me.